The history of this pond and how it's meant to function, or how it does actually function.
So when I came here 15 years ago, none of this development you see called an eyesight around here existed. There was nothing here but green fields and forest land. And we had this designed as part of the function of looking after the bowl, the 260 acres of land, roughly you mentioned, Ian. To this point it's about 180, I'm guessing. And how we're going to control the flows going down the existing draw on the land to the lands below. So the plan was to have a joint use park, playing field, passive park area and storm detention facility. So the flows coming from the hill this way come down, they go through a right of way just behind that small landscaped area. Between that and the swing sets, across to the other side, picks up the drainage coming around from all the east side of the land here, comes through a pipe and into this chamber below us. And what's below us is a fairly large pipe coming in, fairly large pipe going out down there, we'll look at it, and the overflow back into the pond behind us here. And again, as Ian said this morning, we have a steel plate in here. There's a wall with a steel plate down here, and that's got a hole in it this size. When we first started, it was this size. We kept on burning it bigger as development increased for the pre and post development flows. You've heard about that? Yes? No? Okay. So when you design or develop a piece of land, you try and ensure that the flows that were draining from the land before you develop equal the flows from the land after you develop for a certain storm event.
Were you just going after peak flows?
We were going after peak flows. So the peak flow getting shaved off here goes in the park. The base flow goes downstream.
Do you have any monitoring stations to give you some idea of what kind of flows are coming in and out?
No. So we did the design, but we didn't follow through at the end part yet.
I did actually.
Ian did, I did.
On my own though, you know, because I was younger then and full of enthusiasm. And not that I'm no longer.
Something in vinegar?
Anyway, I used to come out here when it rained hard and when this pond was functioning, and I would call the weather people at the Atmospheric Environment Service at the air base here. We've got the luxury of having a federal air base right nearby, so they give us pretty good data. And I would correlate the return period storms to the function of this thing and try and get a handle on whether it was functioning as anticipated. Yeah, I did do that, but there are no specific monitoring stations.
So did you maintain the pre-development flows?
Yeah, in large part. But really though, you know, like we talked about this morning, all we were doing was shaving the peak off the hydrograph there, which is really only part of the problem. It's really only part of the solution in a rainwater management context, right?
Did you get a concept of how much volume you were actually able to infiltrate back into the ground here?
You know, I'll tell you what.
Able to recover some of the volume?
What I'd like to say is that at the time this pond was conceived of, this subdivision around us had already been approved, and this was parked. And Kevin came along and said, he just joined the city of Courtenay, and he said, well, you guys, there's no stormwater management plan here. At the time referred to as stormwater management. And so, you know, he made a compromise solution with this land developer to try and make a joint use facility here. But at that time, and this was in the early 90s, there was no comprehension in our minds relative to infiltration and groundwater recharge. So really this is, the intent here was live storage to the tune of about 100 cubes per hectare. And it is what it is. It's the first stage, and that's why we're here, to show you sort of the evolution of the design of these things.
So sorry, go on.
What dollar value do you recall this?
Oh, I can't
bulb?
remember, no, I'm sorry.
Not a lot compared with today's costs.
Yeah.
So when we were designing things like this back in the early 90s, we were using 28 years of rainfall data from the Comox air base. That's all it was. We were designing 5, 10, 100-year storm events based on 28 years of data. In 1997, we had a 1 in 50-year storm event on that database. And 1 year later, we had a 1 in 100-year storm event based on that database. What we then did was we added a 25% increase to all those models to make them reflect better what was happening. And the reason for that is normally the airbase would have done that, but they couldn't get to that subject because they're looking at all of Canada. So we did our own thing locally. When the data came out years later, it was pretty close to what we'd actually predicted. Yeah. So we were on the right side. It would sound like a big jump, 25% more rainfall than we've been designing for before, but that's what we did. Hence the reason why the plate there keeps on getting a little bigger, depending what we're going to do. And that plate, of course, is a big pipe out, small plate in the way. It holds the flow back, which backs this pathway through that head wall you see behind the support. So this will hold 3,000 gallons of water.
Cubic meters?
3,000 cubic meters. About 67,000 gallons of water will be backed up in here. If it overflows, it goes over here. I've never seen this overflow, and I lived in the house there that we walked past with a white railing for 10 years. The flow never overflowed.
But how often does it back up into the pond?
In the pond, or maybe once a week, to varying depths. But to the depth of almost the overflow once a year. But it never went over the top of the house. And if you ever observed it,
That sort of speaks to the continual events, right? Like the idea wasn't brim full on a Q2 storm, but the lesser storms would still cause a little bit of that.